So now we want to know, how do homogeneous systems relate to a corresponding linear system? So let's consider these two systems. The only difference between the two is that the first one's homogeneous and the second one isn't. We've just solved this first one here. We got that x1 is equal to x3. We got that x2 was equal to 0. And x3 was our free variable. So what about the corresponding linear system? Well, let's put it in a matrix and row reduce. So 2, 3, 4, 8, 7, 6, minus 2, minus 3, minus 4, and 4, 5, 6. We want the 1 in the first row, first column, so we will once again multiply by 1/2. This gives 1, 4, minus 1, 2. Second and third rows will be left alone for now. The next step would be to get zeros underneath this 1. Minus 3 row 1 plus row 2 gives that first 0. So we have negative 3 plus 3 is 0. Negative 12 plus 7 is negative 5. 3 minus 3 is 0. And negative 6 minus 5, which is 1. To get the second one, we'll do a negative 4 times row 1 plus row 3. So negative 4 plus 4 is 0. Negative 16 plus 6 is negative 10. 4 minus 4 is 0. And then negative 8 plus 6 is negative 2, or is positive 2. From here, we need to turn the second row, second column into a 1. So we'll do this by multiplying by negative 1/5 times the second row. So as rows 1 and 3 will stay the same. And row 2 becomes 0, 1, 0, negative 1/5. Next, we want the zeros above and below this 1. To get the first one, we'll do negative 4 times the second row plus the first. That gives 0 plus 1, which is 1. Negative 4 plus 4 is 0. 0 minus 1 is negative 1. Positive 4/5 plus 2, which is 14 over 5. We'll also do 10 row 2 plus row 3. Zero plus 0 is 0. 10 minus 10 is 0. 0 plus 0 is 0. And negative 2 plus 0, or negative 2 plus 2 is 0. So we'll see this also has infinitely many solutions. And if you work it out, you get that x1 is equal to x3 plus 14 over 5. x2 is negative 1/5, and x3 is our free variable. It can be any value. So these two solutions are actually very related. So when you're dealing with homogeneous systems versus linear systems, the only difference are these constant values in the solution. Originally, we just had x3. Now we need to add a constant since it's no longer homogeneous. x2 was originally 0. Since it's no longer homogeneous, we should add a constant to that, which we did with -1/5. The free variables will remain the same.